Hello and welcome to the UNICAT channel. Today I would like to talk about electric drive systems. Everybody is talking about electric drive systems these days, and I had the opportunity to visit large exhibitions for truck technology, and all the major players are just showing electric trucks with batteries, with hydrogen, whatever systems. That's all they are talking about. So probably some of you are also asking yourself, well, is that something for an expedition vehicle? Can it be done now? How far are we away of that? I would like to give you a brief overview of the old and new energy sources which can be used. I would like to give you a comparison of the effectivity of the old ones compared to the new ones. And all that is based on the information which are publicly available. I just want to tell you the reality, how I see it. The first and basic question is, how much energy does a truck need to run a distance of 100 kilometers? If you look at the consumption of a truck today, a diesel truck, we are looking at about 26 liters per 100 kilometers. We are talking off-road vehicle, so the resistances are a little bit higher. So let's add 20%. Or let's say as a diesel truck it would need about 30 liters per 100 kilometers, or as an electric drive 120 kilowatt hours per 100 kilometers. That also meets the information the manufacturers of electric trucks provide today. So in average they calculate with 100 kilowatt hours per 100 kilometers. We calculate now with 120 kilowatt hours per 100 kilometer. So 100 kilometers is not a long distance. So we should look at a distance of 500 kilometers. So we just use the numbers for 500 kilometers. Now if you have a diesel engine and it consumes 30 liters per 100 kilometers, then it's 150 liters for 500 kilometers. That's very easy. And 150 liters of diesel is a relatively small tank, and the weight of 150 liters of diesel is about 130 kilograms. So that's not a lot. Batteries are much heavier and much larger. And even hydrogen tanks and the fuel cell are much heavier and larger. So the bad news is at this stage of technology, the volume and the weight of a hydrogen-driven vehicle is about 15 times worse than a diesel truck. And a battery-driven vehicle compared to a diesel-driven vehicle is 30 times worse. So you need tremendous volumes and weight to get out of batteries or get out of hydrogen what you can get out of 150 liters of diesel. So that's really the challenge, and yeah, well, that's also the limiting factors, besides recharging. Well, the other bad news is that diesel fuel is available pretty much everywhere, and it's not very temperature critical, and on the other hand, you hardly will find charging stations or hydrogen supply in remote places. So let's have a look at the different options. So I would say the first one is a battery system with an electric motor, a plug-in electric drive system. So it consists of a large battery pack that is providing electricity for the electric motors, which are finally driving the wheels. That's pretty straightforward, and that's what some manufacturers already offer today, but they only offer it for let's say tractor trailers or commercial trucks or delivery trucks which go into the city. So the range they can handle today is about, let's say, 500 kilometers, but that means they have a huge battery pack on board. So to go a distance of 500 kilometers, you actually need about a battery capacity of 600 kilowatt hours. And that will add about 4 tons, 4,000 kilograms to the total weight of your vehicle. And you will need about a volume of 4,800 liters for that battery pack. And I have already deducted the weight and the volume of the big diesel engine. So instead of 150 liters of diesel, you need approximately 4,800 liters of volume for those batteries. Those heavy batteries which add 4 tons to the weight of your truck. So the second system that is now going into the market is a truck with a fuel cell and hydrogen as an energy source. So what happens is that you are filling hydrogen into your tanks, and typically in vehicles there are huge tanks where you have the hydrogen not liquid but as a gas, and the pressure in these tanks is already 700 bars. That's a lot of pressure for a big tank. Okay, so what happens is the fuel cell burns the hydrogen with oxygen and creates water, and that provides electric energy. And this electric energy then is used to supply to electric motor, which is driving the wheels. Now, a fuel cell is limited in its capacity to produce electricity. So, for example, on the exhibition, I have seen fuel cells of a capacity of 100 kilowatt output, and if you use 2 of these cells, you get 200 kilowatt output, and that's the volume and the size of a big diesel engine. But now we are saying, okay, we need 120 kilowatt average power to go at that speed. But sometimes when you're climbing or when you're accelerating, you might need 300, 400 kilowatt of power. If you have a battery system, it's no problem. You just draw more power, more amps from these batteries, and they do the job. Now, a fuel cell this type of fuel cell, for example, can only provide 200 kilowatts. So that would be your limitation. And as you don't want that limitation, they put also a small battery pack into the truck to compensate the partly high demand of power. So now, as long as you don't need more than 200, which is when you're rolling along the highway, then you are fine. But if you are climbing or accelerating and climbing, then you might need 300-400 kilowatt, and then 200 comes from the fuel cell and the rest comes from the battery. And when you are going downhill, then the fuel cells can charge the batteries because you don't need power. And also, we always have recuperation on electric drive motors, so they are also recharging the batteries. But you need a battery pack to do some compensation. So if you want to go 500 kilometers on hydrogen, you need to have huge gas tanks, hydrogen tanks with high pressure. You need the fuel cell, which can provide 200 kilowatt, and you need a battery pack. And that will add like approximately 2 tons of weight and also a lot of volume just for the tanks, which depends on the pressure the hydrogen is stored with. There's also the opportunity to store hydrogen liquid, but that has to be done at minus 253 degrees Celsius. That takes a lot of power to cool it. And if the cooling wouldn't work, the hydrogen would expand and would have to be released to the environment, which is not that great. But then it would only be a fifth of the volume compared to the big tanks with 700 bar. Another solution is to make a hybrid. A hybrid consisting of a battery pack, which can be recharged by plugging it in, or which can be recharged by a diesel generator. You can also charge it with solar, but I will explain that in the next sentence. So let's say you have a battery pack of 300 kilowatt hours. 300 kilowatt hours brings you 250 kilometers on electricity without running a generator. If the generator has 60 kilowatt output, you can recharge your battery pack within 5 hours, approximately 5 hours. So you're kind of independent from a charging station or other power sources. So that's a good thing, and sounds like a more real thing for an expedition vehicle. Now, if you can also run that generator while you are driving, and if 60 kilowatt out of the 120 you need per hour comes from the generator, then you only have to draw 60 amps per hour from your battery. 60 kilowatt from your battery means the 120 kilowatt you need in total comes half from the generator, half from the batteries. Means you cannot only go 250 kilometers, you can go 500 kilometers. So if you run your smaller generator, 60 kilowatt, I mean, it's not really a small generator, but 60 kilowatt is a 4-cylinder motor. If you run that, you can go 500 kilometers and have your batteries empty, and then you can recharge your batteries within 5 hours. Now, that sounds a little bit strange to say, okay, I run a diesel to make electricity. The electricity is put into the batteries or partly directly into the motors. And it sounds not very efficient, but in the end, it's as efficient as other systems as well. Because a diesel generator is an engine that runs under perfect conditions. It runs at constant RPM, and that means that the efficiency of that diesel engine can go up to 50% or even a little bit more. while a diesel engine, which is normally running on different RPM and different loads, typically has efficiency of 40%, maybe 45%, but in some situations only 25 to 30%. And the electrical part, which means we are charging the batteries and we are discharging the batteries and putting it into an electric motor, this is a very high efficient system. That means that pretty much all the energy you put into the battery, you can also take out again. There is hardly no loss. And the electric drive motor has an efficiency of like 95%. So on the electrical part, you're not losing a lot of power. And if you run your generator under perfect conditions, it will have a very high efficiency rate. So that's working. I mean, it's also used on big ships where they run big diesel engines and then they make electricity, and the electricity is driving the propeller. Not only on submarines, also on commercial ships, and they know what efficiency means for them. So this system is, I would say, available and could be used for expedition vehicles. But even this solution has more weight and more volume than a regular diesel drive system. So you have to calculate for the 300 kilowatt hours battery pack which you need. You have to calculate for the generator. You have to calculate for the diesel fuel, which is not a lot. And you can delete the diesel engine and gearbox and so on. But you have to calculate with 2 tons additional weight and about 3,000 liters. I mean, what you can do, you say, okay, I don't need 500 kilometers range per day. Then you can reduce the battery pack, or you can make a larger generator. So, but that half thing, I think, was a good example. I mentioned that you can also use a solar system. I mean, this is the question which is often asked. Can't I just put a big solar system on the roof and then the solar system is recharging the battery? I would say no, because your battery pack has 300 kilowatt hours. Okay, let's say your solar system provides 3 kilowatt peak, and let's say it provides 3 kilowatt peak, which is the area of a normal roof of a vehicle. It provides that for 10 hours per day, which is a very, very optimistic approach. But 3 kilowatt, 10 hours means 30 kilowatt hours of energy per day. 30 kilowatt hours per day means you need 10 days to charge your batteries with 300 kilowatt hours. And that's under ideal conditions. If the weather is bad, if you have snow on the roof, if you park under trees, you will be sitting there for weeks until your batteries are recharged. So it's a nice addition, but typically a solar system is fine to provide the energy you need for the body, for the light, for the fridges, for cooking, maybe for air conditioning. So you should not use or calculate your solar system as a help for the drive system. That's not working. Now we have spoken about the different ways to provide that electric energy to drive the vehicle. All the systems have commonly electric motors to drive the wheels. And the electric motor is really a super simple thing, no maintenance, no injection, no nothing. You apply electric power to it and it starts turning and just does a job, and it can last for a long time. So that's a good news, and they are not very heavy for the power they provide. Now, in electric motors, you read like average output or constant output and peak output. So other than a combustion engine, which has just a limited maximum output, you can actually increase the output of an electric motor almost unlimited. Yeah? The point is that the electric motor either turns too fast from a certain point on, or it's getting too hot. Typically, the thermal problem is the bigger problem. And even so, all these electric motors are cooled either by water cooling or by oil cooling. They can only run on a higher output for a limited time. But they can run on twice the output of what they put out in average. So let's say we have a motor or a motor package which can provide 200 kilowatt, which is sufficient to normally drive a truck. But if you want, you can push it to 400 kilowatt, 350, 400 kilowatt for a short time only. But I mean, acceleration or climbing typically is limited. And I mean, if the motor gets too hot, they reduce the output, and then your climbing won't be that much as before. Now, electric motors also provide their power, the torque, pretty much constant over the complete range of RPM, which starts at 0 and goes up to like 10,000 RPM. Now, you always need a kind of gearbox or transmission box, because the wheel speed is like maybe 100, 200 RPM per minute, while the electric motor can run at 10,000 RPM. So that has to be transferred down. But in some cases, it's better not only to adapt the speed ratios, but also to add a 2-speed, 3-speed or 4-speed gearbox. The reason is that a normal car or delivery truck that does not have to climb extremely, or that does not have to accelerate extremely, you simply don't need a 2-speed gearbox, because there's always enough torque to move the vehicle forward. And saving a gearbox saves energy, saves money, saves weight. So if it's not necessary, nobody will do it. But in many trucks, especially those which carry a lot of load, or which are designed to do really steep climbing, they put a two-speed gearbox between the electric motor and actually the axle or the wheels. And some even do a 3-speed or 4-speed gearbox. So where do we put these motors? There are different options which have advantages and disadvantages. So one option is, and that sounds like obvious to do that, is to put them directly into the wheels. You have quite some space inside the wheel, and And there are systems which do, let's say, wheel motors. Yeah? But the disadvantage of wheel motors is that you increase a lot the unsprung mass, because the wheel is moving, and the driving comfort is getting worse the heavier all that unsprung mass is. You try to keep that as low as possible. Also, if you install a motor here, the motor gets all the shocks and vibration and so on. And it's closer to the road, so there is more dirt, more water, more chance to get mechanically damaged. If it sticks out too wide, it also affects the steering in the front, not so much in the back. But I mean, especially the big unsprung mass and the hard environment for the motor is probably the reason why the big players don't do wheel motors anymore. I haven't seen many in the past years, and I hardly have seen any on those exhibitions. Another option to mount the electric motor is just to put it in the place where the diesel engine was before. Take the diesel engine out and you attach the electric motor to the gearbox. To the original gearbox, which provides you more gears than you really need, or you attach it to a special gearbox which has only 2, 3 or 4 gears. And then you use the rest of the drivetrain. You use the transfer case, and then from there the shafts go to the rear axles, to the front axle. You have your differentials normally working. You have your differential locks. Everything is working normal. You're just replacing the engine, the diesel engine, by an electric engine. That's well, I mean, you have all these parts still in the way. And if you have a battery pack, normally you want to mount your battery pack underneath the chassis. Battery packs are typically that high, and they are arranged in packs which are like 800 millimeters wide, and they are 2.4 meters wide. So they go from here all the way to the other side. But that doesn't really work if you have a transfer case and prop shafts and everything there. So in a situation where you just replace the diesel engine by an electric engine and keep all that drivetrain, then you can only put your battery packs on the outside with limited space, and that means limited range. Well, these are pretty much the disadvantages. The advantage is that it's a very reliable system, because these axles, these suspensions, differentials, all that is in the market since decades. And all you change is the engine. And if you change it to an electric engine, you don't even get vibrations on the drive shaft anymore, because the electric motor runs so smooth. So it's very reliable. You can almost install it without testing, because you're going to know it's working. And actually, that system is used by companies who convert existing diesel trucks to electric trucks. That's done quite a lot. I mean, not too much, but they do it with buses, they do it with commercial trucks, and it can also be done with off-road trucks. So that's an option that can be done today. Another way to install the motors is to attach them directly to the axles. I've seen that in quite a few trucks on these exhibitions, and it seems to be the preferred solution for some manufacturers. So what they do is that they install two electric motors next to each other, and those motors are working together. The reason is that if you look here at the axle, so they attach it in that place. And of course you have more space into the width than in the height. But now an electric motor is always round. So what you can't do is to put a big diameter electric motor. No, but you can put two of a smaller diameter next to each other. So they are combined, and these type of axles, they are also made with a 2-speed gearbox attached inside. So that is an axle with an attached electric drive system. So you don't need drive shafts, you don't need transfer case, you don't need any other gearbox. The disadvantage, in my view, is also that you have the weight attached to the unsprung mass. Because that whole axle, this is a beam axle, this goes up and down, and with the up and down, the motors go up and down. And they are attached off center, which I think is also not ideal. But it seems to be a very economic way to attach these motors to the axles, and I mean, it's okay, and why not doing it that way? But still, same disadvantage like with the wheel motors. It creates a much higher unsprung mass. Vibrations on the motors, they are closer to all the mud, dirt, mechanical damage and all that. So it's not really ideal, but it's one of the solutions they go for. Now we have heard that to attach two motors to the axle is a common way to do it, and it's quite good. But the disadvantage, as said, is that you increase the unsprung mass, and you get a lot of vibrations on these motors, and these motors move and all that. So pretty much the ideal scenario, and that actually is also available, is to use the axle with independent suspension. These axles have a center housing which typically contains the differential, and then you have the wishbones, and on the wishbones you have the wheel ends and the drive shaft from the housing from the differential housing to the wheel end. Now, as this housing in the center is solidly attached to the chassis, so it's not an unsprung mass. And if these electric motors are attached to this housing, they are not increasing the unsprung mass, they are not exposed to vibrations, they are higher up from the ground, and that to me is the ideal situation. And as said, that's available too. Now, is there a summary? Does all that make sense? Well, I hope I could give you some information, some insight, and explain a little bit how all that thing works. For me, today, the only option that can be realized would be a hybrid system with a generator and battery pack, and then ideally independent suspension axles with the motors attached to the axles. That's expensive. All that electric battery packs, motors, controllers, everything, that's really expensive. And we have to see that we can't build a truck from scratch. We have to buy an existing truck. Could be a pre-owned one, but then you don't have the latest assistance systems. So yes, we can make a hybrid electro truck for expeditions today. It's very expensive, but it's doable. So, but I just hope that you could get some information and got a clearer view on all that. And so I hope you enjoyed the video. If you like it, press the button, and see you in the next videos. Thank you very much.